In this video, we're going to talk about zeros of polynomials, polynomial long division, and also synthetic polynomial division. A zero of a polynomial is a value x equal a such that f of a equals 0. Here's an example. We have the polynomial f of x equal x squared minus 2x plus 1. X equal 1 is a zero of that polynomial because if we plug in 1, we get 1 squared minus 2 times 1 plus 1, and that equals 0. Also, if we let that polynomial equal 0 and factor it, we get x minus 1 times x minus 1 equals 0, and then letting each factor equal 0, we get x equal 1. So zeros are really solutions to the polynomial when you let the polynomial equal 0. And here's a fact about polynomials. If x equal a is a zero of the polynomial f of x, then x minus a is a factor of f of x. And also, a0 is an x-intercept of the graph of f of x if a is a real value. We'll use this later when we graph polynomials. Now this provides us a way to factor higher degree polynomials. Also, this is a way to find all of the zeros. If we can find a single zero x equal a, or a factor x minus a of the polynomial, we can then divide the polynomial by that factor, x minus a, and then what we have is x minus a times a smaller polynomial. We can then often factor that smaller polynomial or find its zeros quite easily. Here's an example. Let's say we know that x equal 1 is a zero of f of x equal x cubed minus 2x squared minus 11x plus 12. What we will then do is divide f of x by x minus 1 and then factor completely and then find the other zeros. Okay, we haven't covered polynomial division yet, so let's assume we already know how to divide this, and we divide this third degree polynomial by x minus 1 and we get the result x squared minus x minus 12. Well, if we divide by x minus 1 and get that result, that means we can write f of x as x minus 1 times that result of x squared minus x minus 12. Well, x squared minus x minus 12 factors as x plus 3 times x minus 4. So now we have the complete factorization of f of x. Furthermore, we can find all the zeros by applying the zero product law. We can let each of those factors equal 0. We get x minus 1 equals 0, x plus 3 equals 0, and x minus 4 equals 0. And we get these zeros of x equal 1, x equal negative 3, and x equal 4. So we just need to learn to divide polynomials, and then we can do a lot of stuff with it. So that's coming next, polynomial division. We're going to start with long division of polynomials. We're going to divide this polynomial x to the fourth minus 2x squared plus x minus 2 by this quadratic polynomial x squared plus x minus 4. First thing you do is set it up in division form as I have shown on the right here on the bottom. And note that since the polynomial we are dividing has no x cubed term, we have to put in a 0x cubed placeholder in our division, and I show it right here. Polynomial division follows the same 4 steps as regular division. You divide, multiply, subtract, carry down. In our polynomial division, the first thing we divide is the leading term x to the fourth by the leading term x squared. X to the fourth divided by x squared is another x squared, and that's the first part of our answer, x squared. Then we multiply x squared times the divisor x squared plus x minus 4, and we get this result of x to the fourth plus x cubed minus 4x squared. We place it underneath, and then following that multiplication, we then subtract that. And make sure to put the parentheses around the entire polynomial that you're subtracting here so you get the signs right. And when we subtract, we have 0x cubed minus an x cubed makes negative x cubed. Negative 2x squared minus a negative 4x squared. Well, we're adding 4x squared to negative 2x squared. That makes positive 2x squared. Now we've done the subtraction, and then after we subtract, we carry down. And what we carry down is this next term x, as I have shown here. Now we start the process all over again, but instead of x to the fourth divided by x squared, we take our leading term, negative x cubed, divide by the leading term x squared. And when we do that division, our next term is negative x. Then we multiply that answer, negative x, by our divisor again, and we get a result of negative x cubed minus x squared plus 4x. And then we subtract that from the result above it, using those parentheses again to make sure we get the signs correctly. So 2x squared minus a negative x squared is the same as adding x squared, so we get 3x squared. X minus 4x is negative 3x. And then our next step is to carry down, and it's a minus 2 that we carry down. Then we start the 4 steps again, but this time dividing 3x squared by x squared, and that gives us a result of 3, and now we multiply 3 times our divisor, place the result underneath, and subtract again. And when we subtract, we end up with negative 3x minus 3x is negative 6x, negative 2 plus 12 is 10. That's our remainder. Once the degree of the bottom result is less than our divisor, we can no longer divide. We place that remainder over the divisor as part of our answer, so we have plus the remainder over the divisor as the last part of our answer. And I ask the question, is this divisor a factor? Well, the answer is no, because there's a remainder that's not equal to 0. Only if you have no remainder or a 0 remainder is the divisor a factor. Now we're going to learn a nice shortcut method for certain types of division. And this shortcut method is called synthetic division. Now it only applies when you're dividing by x plus or minus a number. And we're going to use this procedure to divide f of x equals 3x cubed plus 2x minus 1 by x minus 4. We start by writing all of the coefficients of our polynomial. We had 3x cubed, 0x squared, 2x minus 1. Since there's no x squared term, we put in a 0 for that coefficient. And here's our coefficients, 3, 0, 2, negative 1. Off to the left, we put the value c if we're dividing by x minus c. In this case, we're dividing by x minus 4, so we put 4 off to the left. Now note, if we were dividing by x plus something, that's the same as x minus a negative, and that value c would be a negative value. We'll see that in the next example. And we also draw in this L bracket I have shown here, and you'll see how we use that in the following steps. We carry down that first coefficient of 3. Now we multiply this carried down value of 3 times our value of c. 3 times 4 is 12. We place that result 12 in the next column. Our fourth step here is to add the column entries and place the result at the bottom. So we add 0 plus 12, and that makes 12. We then multiply this addition result by c, and we get 4 times 12 is 48. That goes in the next column. We then repeat this step for all the columns. Okay, so we have 48 plus 2 is 50. 50 times 4 is 200. 200 plus negative 1 is 199. Okay, now that bottom row of numbers gives us our answer. It gives us the coefficients of our answer anyway, along with the remainder. So the answer will be 3x squared plus 12x plus 50 with a remainder of 199, or we could write that as 3x squared plus 12x plus 50 plus 199 over x minus 4. Now the answer is always going to be 1 degree less than the dividend. We were dividing a third degree polynomial, 3x cubed plus 2x minus 1. The answer will be a quadratic polynomial, and then we'll have a remainder with that. Is this divisor a factor? Well, again, the answer is no, because there is a remainder that's not 0. So now we're going to do an example where the divisor is a factor, and then we can use that to find zeros in a factorization. In this example, we're going to divide f of x equal x cubed minus 4x squared plus x plus 6 by x plus 1. Then we're going to completely factor f of x and find all of its zeros. And we're going to use this synthetic division method for dividing. Well, we're dividing by x plus 1. That's the same as x minus a negative 1. So our value of c here is not 1, it's negative 1. Our coefficients from 1x cubed minus 4x squared plus 1x plus 6 are 1, negative 4, 1, and 6. So we place those. We have our L bracket. And then I'm going to go through all the steps here. We bring down our 1. 1 times negative 1 is negative 1. We add negative 1 and negative 4 to make negative 5. Then multiply negative 5 times negative 1 is positive 5. We add 5 and 1 to make 6. Then multiply 6 times negative 1 to make negative 6. Then we add negative 6 and 6, and we get 0 as a remainder. So our answer here is 1x squared minus 5x plus 6 with 0 remainder. And that means that x plus 1 is a factor, and we can write the factorization. Since dividing f of x by x plus 1 gives us this result of x squared minus 5x plus 6, that means that f of x equals x plus 1 times x squared minus 5x plus 6, and x squared minus 5x plus 6 factors as x minus 3 times x minus 2. So f of x factors completely as x plus 1 times x minus 3 times x minus 2. And now to find zeros, we let f of x equal 0, and we solve the equation 0 equals x plus 1 times x minus 3 times x minus 2. By the zero product law, we can let each of those factors equal 0, and this gives us solutions of x equal negative 1, x equal 3, x equal 2. These are the zeros of the polynomial. So as you can see, the remainder tells the story. If the remainder is 0, what you've divided by is a factor. If the remainder is not 0, then it's not a factor. And also we're going to learn that the remainder tells us even more about the polynomial. That's coming up in the next video.